Cercando, so using a favorite punti.
So you can just sleep well tonight, having this done with nothing, no problems. There's no problem that I know about. Well, yeah. You fear that there's a non-trivial chance that somebody in this room has positive for COVID tomorrow. Which is in LA. I don't want to say that again, but then you got to tell everybody. Yeah, at this point, my wife just had it. It's actually very, it's weird. Somehow my wife got it, and we were at my son's graduation in Atlanta. My daughter got COVID because she got as we were going to leave, like graduation. My wife was scheduled to be on a 9 a.m. flight the following morning, 11 o'clock at night. My daughter tests. She tested positive for COVID. She tested the second time, and she's still positive. So my sister got it. So I drove. I took one for the team, and me and my daughter got it. Me and my daughter drove from Atlanta to Madison, 12 hours in the car. Just the two of us when she had tested positive. And I never got it, and my wife did. Who was not in the car? I mean, we were masked. Yeah, we had masks on the whole time. And but still, we were like 3 feet away from each other for 12 hours. It's just bizarre. Yeah, exactly the same way. Yeah, my wife and one daughter got it. My wife and the other daughter did not. Yeah, but it's when my wife got it, it was less than a bad cold. She got tired of being stuck inside when everybody else was out, right? I mean, it was one thing in COVID when we were all stuck, but I don't want to spread it though. That's why I'm not worried about me. Yeah. But I would avoid, my wife didn't fly.
Let's come on.
Yeah, sorry. I mean, it's the last time you'll hear my voice.
Not last. Tu stai usando un No, height.
The other thing come in while you're speaking.
Ok. Possiamo iniziare con la diretta?
I think so.
Okay. Let's start our third lecture, and which will conclude our 12th edition. So first of all, thanks to all of you. So it's the last time that I will introduce for today, and thanks again to the three speakers for being here. And now the talk of Chris Tabor, PhD in economics at Chicago, started his career at Northwestern University, and then in 2007 moved to Wisconsin. where he's now worker family distinguished chair in economics. He has obtained several awards. I think this year he got Wolf Ekman Professor of Economics, and he has served as Associate Editor of Econometrica, Editor-in-Chief of Joly, then QE, and his research interests vary from labor economics, applied econometrics, public economics. Also, he worked on some non-experimental methods for evaluation. And in economics of education, his work includes studies on the effectiveness of Catholic schools and of voucher programs, importance of borrowing constraints in college-going decision, general equilibrium models of labor market. He has widely published on AR, Econometrica, JP, Stat, Joly, JCHR, and the others. And today's talk is on understanding college dropout. You have 50 minutes.
Okay. Is there a clock?
Yeah, we'll keep the time.
Okay. All right. I'm not going to use a microphone. I think I'm loud. Yeah, I've used a large lecture, so hopefully I'm loud enough. First, thank you to the organizers for inviting me. This has been a great conference. I've never been here before. I really enjoyed the last couple of days. And thank you to you guys for staying around so long. Except for Susanna, you should be celebrating your anniversary with your husband rather than listening to me. I'm gonna. First of all, I would like to take questions. Take questions while I'm going. I have 3 kids. I went to the University of Chicago. I get very uncomfortable talking without people interrupting me. I'm gonna start with 2 apologies. Apology number 1. Education is part of what I do. It's an important part of what I do, but but I don't have there weren't lots of things that I could present. So I'm going to present 1 paper, and not only am I going to present 1 paper, it's going to be a very preliminary paper, and it's the first time that I presented it, which is not ideal for a keynote, but I very much appreciate comments because it is very much work in progress. It's a structural paper. It's less far along than I would have liked when I agreed to do this at the beginning. The second thing I apologize for the title. A better title would be I Don't Understand College Dropout, rather than Understanding College Dropout. Basically, this I'll speak for myself, not necessarily for my co-authors. I got into this thinking about college dropout. There's college dropout in the US, and everywhere else. College dropout is very large, and it's sort of hard to understand. Why is it that people are dropping out? Is this an optimal thing that we shouldn't be worried about it, or is there some major problem that we should be worried about? And then potentially, if it is a problem, what can we do about it? What are the government? If we want to solve the problem, what are the potential interventions that we can do to solve the problem? So, by no means have we answered this question, and probably there's many of you in the audience that know more about this than I do after writing this. But hopefully we have something interesting to say. So as I said, this is very much a work in progress. So here's the game plan. Some might argue that this is a nice way to me, for those of you that don't do structural work, maybe this is an interesting way that you might think about why structural work is interesting. Basically, what I'm going to do is I'm going to start with a bunch of data. We're going to start with panel data, analyzing the data, looking at the patterns of the data, and then we want to look at 2 different subsidy programs with random assignment. I never know whether both of these are programs where somebody wanted to give a lot of money to college students, and academics convinced them to randomize among some dimensions. So it's not, I guess it's not an RCT because it was designed as an actual program, but we have random assignment. So two things on that are nice. And then the model, but essentially the point of the model is to put these things together. Kind of the point of the structural model in this case is to try to make sense of these data and then try to think about what we might do to solve the problem if indeed it is a problem. So I'll show you some results that we have from the model and some counterfactuals. Okay, so the first data set probably most of you are probably familiar with. If you're not, the Analyst Y97. So this is a panel data set starting with kids who were 12 to 16 as of December 31st, 1996, and then follows them every year for a while, and then every other year. The goal of this paper is we're not focused on the labor market at all. The goal is just to understand the dynamics of college. So we're going to look at people moving in and out of college. So basically, we're going to follow people, not basically, we are going to follow people from the time at which they graduate from high school until age 25, okay? Our main analysis, so what we're going to use to estimate the structural model is going to be a much more complicated thing than I'm going to show you. It's going to be basically a Markov model where you have separate coefficients for all of the different transitions that people might make. But I can summarize it pretty well using the following thing. So what we're going to do is we're going to look at people that are age 25, and I'm going to divide them into 5 mutually exclusive categories. If you got a bachelor degree, you're in this category. If you got an associate's degree and not a bachelor degree, you're in this category. If you never went to college, you're in this category. If you went to college but never got a degree, you're in one of these 2 categories. Some people do both and don't finish. I'm going to put whichever one you started. That's what I'm going to do. So this is just for descriptive purposes. It's a pretty useful way, I think, to see what's going on. So here's the basic data. So there's 5 different groups. So you can this is the no college. This is together the 4-year college. These are the guys who began but did not get a degree. Red got a degree. Same thing for 2-year colleges. Okay. So the stunning thing here is the small fraction of people that actually get 2-year degrees. It's a little bit unfair. I'm calling this dropout. That's not really fair because some of these people they took a few classes. They never intended to get a degree anyway. We're not conditioning them wanting to get a degree, but very few people go and actually get a degree. Yeah.
What about people transferring from 2 years to 4 years without actually getting 2 years? It just kind of seems that they move into the 4-year degree, so they don't actually get a qualification, but you don't see that in the data. Does that happen?
So people move.
They just move, they just move
from 2 to 4 and never get a degree. Oh, it definitely happens.
Never get a 2-year degree, but do get a 4-year degree. So you could have some measurement error in that.
Yeah, we're gonna have people like that. Yeah. No, we'll have people. Yeah, there's no. I mean, when we're actually doing it, there's no measurement error. We're accounting for people like that. In this little exercise, those people would count as college graduates. And if they didn't get a degree and they went to 4, they would count as 2-year because they started at 2 years. So again, this is like what we're doing in the model is much more complicated in accounting for all of the different transitions you make, but I'm just trying to simplify it here to keep it to make it clear. So I'm calling these dropouts. To be fair, like I said, many of these people weren't necessarily intending on getting a degree in the first place. Look at it across different groups. So this is the difference between men and women, and you can see kind of the well-known fact that women go to college at substantially higher rates than men, and you can see 2 years are pretty similar. So most of this is at the 4-year. You can also see that women, they're not doing great, or they're still dropping out really high rates at 2-year, but they're graduating at higher rates than men, both at 2-year, not by much, but a little bit, and especially 4-year. Women are doing a little bit better. Next group is by race. So again, not surprisingly, blacks are getting less college than whites, and are also graduating at lower rates. Okay. The next 3 things, what I'm going to do is they're continuous variables. I'm going to put all of them into terciles, and then I'm going to plot each of the 3 terciles. Okay, and all of these, none of this is like everything. I'm not doing anything new. Maybe I'm showing the data in a different way, but I don't want to claim that you're learning anything that nobody's ever done before. But even for people that have seen it, some of these results are really stunning. So this is by income. So we take family income. These kids are young enough that we get to observe their family income their parents' income while they're at home. And so we're just graphing this by family income. And you can see that the high income tercile goes to college at way, way higher rates than the bottom tercile and graduates at way, way higher rates than the bottom tercile. Yeah.
So you're here to 24 years. Is this both 24 years?
I'm doing exactly the same thing that I did here, right? Except that, but so there's the 3 no college. Yeah. So then it's still 5 groups. There's now 15 groups, like 3 by 5. Okay, does that make sense? Okay, AFQ test score. The AFQT is a standardized test score that's used in the LSY. You may or may not have heard of it, but think about it as a standardized test score. Again, huge differences, right? Like there's almost nothing that predicts anything in labor economics better than AFQT predicts college attainment, or at least enrollment. GPA is even stronger. So people that I guess I really just contradicted myself. GPA is stronger than AFQT. Again, you can see huge differences in GPA, both in terms of college enrollment, but also in terms of dropout. Right? It's still, most people are not getting a degree, but the fraction here is bigger than anything else that we look at. Here, let's let them compete. So we're going to do, again, 2 of these are just this simple descriptive things to give you an idea of what's in the data. This is a multinomial logit for whether you're in one of the 3 categories for starting. And no causal interpretations. This is descriptive. Let things compete against each other, and pretty much everything that you saw is going to show up here. So women are more likely to go to 2-year and to 4-year. People with higher test scores are more likely to go. People with higher GPA are more likely to go. People with higher family income are more likely to go. There's something else that, again, this is I remember seeing this for the first time when I was doing my dissertation in 1992 or whatever. Once you control for test scores, the Black-Stein reverses. So the conditional on grades and test scores and family income, you actually see that blacks go to college at higher rates than whites. Okay, so these controls matter a lot. Now we're going to look at completing. I'm going to throw one more variable here because it's somewhat obviously endogenous. We're going to look at college GPA as well. Things here are pretty similar, except for the ASVAB variable went away, right? So it's super predictive at whether you go to college, but it turns out not to be very predictive for completion. High school GPA is just out there. High school GPA, conditional on all this other stuff, is gonna be really important. You guys see that the female effect went away, right? So once you control for these other things, the most important which is high school GPA, and then the difference between here and here, controlling for college GPA as well. Once you control for these, the female sign becomes insignificant. Okay, so that's the basic data. That's the basic NLSY data that we want to talk about. Let me talk about the 2 experiments. The first one is the Wisconsin Scholars Program, which is there's a whole series of papers by a combination of these 5 authors. This one, Sarah Goldragrava, I don't know how many people know her. She's a sociologist. She's on every single one of this. She's the driving force of this. This is my co-author. Doug Harris is the co-author on this paper. This is also a project I know pretty well. Both Doug and Sarah were at Wisconsin when this thing started, maybe not surprising that it's Wisconsin. I was kind of a consultant and involved in the project at the beginning. I worked on it to see. I never wrote a paper with the data, but I kind of know this better than sort of a random person off the street. So this is really nice for this particular question. And frankly, I think it was working on this project that got me interested in this paper a while ago. So what's interesting about this paper and what's really nice about this paper for the purposes here is that randomization occurs after you go to college. Okay, so the problem is that randomization occurs before you go to college. Now, going to college is endogenous and separating these effects out so you don't have a clean causal effect of college. But here, you show up to college and then all of a sudden you just get a letter in your mailbox saying, here's a whole bunch of money to help pay for college. The goal was to provide funds for low-income college students. It was targeted at low-income students. So the Pell Grant is the main means-tested college grant program, nationwide college grant program in the U.S. The donor wanted, the person that gave, I guess I should use the word donor. The person that gave the money wanted a sizable chunk of money. So rather than give small amounts to a large set of people, she'd rather give larger sets of amounts to a smaller set of people, which is where you got randomization. So the team above that team convinced her to do this thing as a randomization. The first one is really nuts because you have no idea this is coming. Like the program didn't exist before. Suddenly you're a freshman in college and you get this letter saying, here's a whole bunch of money. Use it. You can use it for college. There's you got to keep up your GPA and things like that. So it's a little bit more than money, but not much more than money. The results are going to be depressing. It basically didn't do anything. Okay. So real quickly, this is the effect on four-year colleges. So this is the control mean here. This is the treatment effect. So this is the for whatever this outcome is. This is the difference between the treatments and controls. I mean, the work, degrees, whether you actually got a degree, right? That's the thing that I was sort of most interested in. How are these things going to help degrees? The point estimate is negative, okay? So this extra money did not lead people to get degrees, and you see almost as many negative numbers as you see positive numbers. So this thing really had very little effect at the 2-year level. It was a little bit more effective at the 4-year level, but not so much. At the very beginning, it looked kind of encouraging. So that you saw positive effects on staying past one semester, positive effects on a second semester, but then it went on, and the degree completion, 5-year degree completion is significant with 1 star, so big standard errors, but still a pretty small effect, right? So we're only increasing college graduation by 2 points off a base of 52. To make it even kind of work, somehow 9 years later, the effect is negative. We're stopping at age 25. That's beyond age 25. So we're not going to try to explain that with our model, and I don't know how we would. You do see, and we're not going to think about this, but you do see that people are more likely to move into STEM. So it might be that people are more intense in what they're doing, but on the extensive margin, this program had very little effect. Another one that you might have heard about is the Susan Thompson Buffett Scholarship. This is Warren Buffett's ex-wife, and this program has been around for a very long time. I know much less about this program, but it's more complicated. I'm not going to try to get into all the details of how it works. Depending on exactly what you do, you can get up to $70,000. Okay, if you stay in for an expensive 4-year school and you have sufficient need. So this is a very generous program. It's a little bit weird for our purposes. It's kind of nice and kind of not. You apply for the scholarship in your senior year, okay, and then you learn whether you want it in your senior year. So the problem for us, where that's going to make things a little bit, you can see that the control mean for going to college is going to be 96%. So the set of people that are applying for this are pretty much people that are already decided to go to college. Basically, the way the random assignment worked, the way that they did this was you look, people submit applications, you look at the applications, you rank the applications. They convinced them to put them into 3 different groups: a high group, a low group, and a medium group. Okay, the high group got the scholarship for sure. The low group, no scholarship for you. The middle group is where they did the randomization. Okay, so they convinced them to randomize in the middle. Here it's a bigger program, but here we're going to see some effects. Basically, nothing on 2-year again, but there are going to be effects on 4-year, which is good because this is a pretty generous program. At the beginning, when you apply, they ask whether you intend to go to a 4-year school or you intend to go to a 2-year school. So this is the people who intend to go to a 2-year. This is the people that intend to go to a 4-year, but you don't have to actually go where you said you were going to go. But you can see that there is, I mean, the award effect is 0.026, which doesn't sound all that high, but on a base of 96, that's pretty good, right? When people that win pretty much go to college, the 2-year strata is 90%, and it increases by 6%. So you see really big effects at the very beginning. Again, maybe not that surprising. People are applying to it. They win it shortly after applying to it. It would be a little bit strange to go to the effort to apply and then win and then not go to college. Here's the basic changes. So the as you might guess, the gray line is the control group. The black line is the treatment group. So you can see that in general for the 2-year strata, standard errors are pretty big, but you're going at higher rates. Something similar, but a little bit more precise and higher rates as one might expect for the college. Okay, so the overall effect. For the 2-year strata, the effect on associate's degree earned is negative. Okay, so again, there's no effect here, but here's where it's a little bit more, here's where you're getting a little bit of, some of these 2-year people were planning on 2-year thing, then they got the scholarship and they said, oh, let's go to 4-year. And you can see that causes 3.5% of them to end up actually graduating with a bachelor degree. Of course, they might have started a 2-year school and moved on. That's not significant though. Okay, so we're not seeing very much of the 2-year. The 4-year award, we're getting basically the effect is, I don't want to get that much time, so I want to get into all the details, but it's basically 9% off a base of 63%. Okay, so yeah, it's a big effect. Whether it's a huge effect, I mean, you can kind of, I don't know exactly how you want to think about this. This is a big intervention. Okay, it would be surprising if it didn't have a big effect. Okay, so that's the data and the RCT. If you're an RCT data kind of person, you can exit the seminar now. Now we're going to get more into the structural model. It's a pretty simple model. So we're only looking at people from 18 to 25. The people from 18 to 25 are only going to have how much time? No. I'm not paying that. What? 25. Okay. People from 18 to 25 are basically going to only make kind of one main decision. So one main decision is what is my college option for this period? And there's 3 options. I can be in 2-year school, I can be in 4-year school, or I can be non-enrolled. Okay. If you go to college, we're also going to be modeling the loan decision. So you're going to decide how much of a Stafford loan you want to take when you're in college, and that's going to determine what your consumption level is. And I'll give you details of that later. The college degree. People that are saying these kinds of models we often make this assumption, and I'm going to use it as well. The probability of getting a degree is in some sense exogenous, conditional on the years of school. So you're going to stay in school for a certain amount of time, and then hopefully after 4 years you're going to get a BA, but there's some chance that you won't, and then you have to stay an extra year. So yeah, it's not a perfect way of doing things, but that's the way that we're going to do things. And then the model is going to end at age 25. So the way that we're going to specify the structural model is there's just a terminal value function. So at age 25, you exit the model, you live the rest of your life with a certain set of state variables. We're going to estimate the value function of that state variables. It's a kind of reduced form in the classic sense of the world. We're not going to try to think about exactly why these things matter. We're just going to estimate your value of them. Okay. The state space is basically all of the stuff that I talked about before. So these are characteristics of a person that do not change over time, whether they're female, whether they're black, whatever their ASVAB was, whatever the GPA in high school was. FI is going to be family income, so that's not going to change over time. The state that they live in is going to matter because we're going to infer what your net tuition is based on the financial aid. So the state that you live in is going to have something that is going to be used to predict your net tuition that you have to pay. And then we're going to have this new I thing, which is basically ability to learn in college. Okay? We started with a model that the original model we had in mind was going to have learning, so you might not know what your new I was when you start college and you learn about it. There's been other papers that have done this. So far, it's not totally clear that we need that in order to explain the data. So right now, new I is known from beginning, and then the entire state space is given by this omega IT, which are these things that don't change over time. Your age, this is the years of completed 2-year, the years of completed 4-year, whether you have an associate's degree, whether you were in school last year, and the loans that you had last year. Okay? BA is not here because as soon as you, I guess I didn't say that either. As soon as you get a BA, you're done. You leave the model. Like you won, I guess. Maybe that's not really the right way to say it. But we're no longer modeling you because we know that at age 25 you have a BA. Okay, so you exit the model either when you obtain your BA or when you hit age 25. Okay, flow utility. So basically, you're going to care about consumption. You're going to potentially, this can change the number of years of school you had. There's going to be some fixed cost of switching schools to explain why we see persistence in schools. Your age, and then these demographic dummies. And then you're going to have a type 1 extreme value error term. Out of college, like if we were estimating a static simple model, out of college would just be 0. So like often with the multinomial probate, you want to set one of the things to 0. We would set it to 0, but we realize we can't set it quite. We can't set it quite to 0 because things like experience, like if I've been employed in the labor market for 4 years, I should be earning a higher wage than if I just entered. So we're allowing, this thing is essentially picking up experience outside of school, and then whether you have an AA, whether you have an associate's degree, is also gonna enter this thing. Okay, does that all make sense? And then here are the terminal values. If as soon as you get a BA, you're going to get this thing. If you graduate with an associate's degree at age 25, you're going to get one value function. If you graduate without an associate's degree or a college degree at age 25, not graduate, if you reach age 25 without either degree, you're going to get this value function. It's basically the same arguments with different parameters. Notice we're being a little bit like loans is just gonna enter this model with, we're just estimating the distaste for loans. So we're not explicitly thinking about people repaying their loans in a life cycle labor market model. We're just going to estimate the utility of the loans and how much people dislike having loans. Okay. The budget constraint. So this is a little bit goofy relative to. I mean, it looks like a regular budget constraint, so it looks really nice and it looks like something that you're used to. But we don't. There's going to be 3 elements. There's going to be 3 elements here. We have consumption. MIKT, we're going to model this as a transfer from your parents to you while you're in college. So this is money that can be used to pay tuition, but it's also money that can be used to go to the movies and buy beers and beer and all the other things that college students do. Okay, so you're going to get this transfer. You're going to get this transfer from your parent. That's this MIK thing. Then you're going to potentially take out loans. So I can borrow money this period against my student loans, and then I have to pay tuition. Okay, so this is going to be the budget. This is going to be the budget constraint of the kid while they're in college. Why I'm saying it's a bit goofy is because I don't really have that much data. I have some idea about the tuition that they pay. At least I can get a pretty good guess of the tuition that they're going to pay. I know their loans. I can observe their loans NLSY data, but I don't observe the parental transfers, and I don't observe consumption. Okay, so at some level, this is the model is doing a lot of work here. It's going to pick up the fact that kids with higher family income are going to tend to stay in college longer, and the reason why they're going to tend to stay in college longer is because they get these transfers from the parents, and it's going to interact with this effect. Okay, and you're also going to get that loans are going to be worse for low-income kids because they had a smaller transfer, and because utility is concave, the disutility of loans is going to be larger when my consumption level is low, just kind of standard consumption. Think about it. And I apologize for all people that haven't thought about this since they took macro in their first year. Tuition is just going to be something that we're going to estimate outside the model. We're estimating using the data, and then we're just going to give people this amount of data. Yeah.
Does it matter all the parents' contribution doesn't respond to tuition in this?
I don't know. Yeah, it doesn't. The way that we don't observe the parental contribution, so you can imagine that it would. No, the parental it doesn't matter whether you go to 2-year school, 4-year school, or don't go to college. So it's something. It does matter whether you go to 4-year college or not. But we're not. I mean, we could, but we don't have any data to shed light on what that might actually be. But it's a sensitivity analysis. What we could do is a sensitivity analysis. Yeah, I mean, a more complicated model, like my colleague Anant Chaudhry has written down complicated models with games between parents and kids thinking about this sort of thing. We're focused on the dropout decision, not so much that part, so we wanted to incorporate it, but in a very simple way. Okay, any other questions about this? College GPA, it's just a regression model. We're going to model it like this. Degree received, like I said, it's essentially going to be a probe. So it is exogenous, conditional on your state variable. So clearly, the more years of school you have, the more likely you are to get a degree. But conditional on years of school and conditional on your ability to learn whether you get a degree or not, and these other X's, whether you get a degree or not is going to be exogenous. Okay, and it's going to happen at the end of the period. So the timing within a period is first I make a decision about whether to go to college. Then while I'm in college, I consume and I go to school and I learn stuff. Then at the end of the period, I get a draw to see whether I get a degree or not, and then I do it all again the next period if I don't get a degree. Okay. So that's it. That's a model. It's not a super simple model, but it's not a super complicated model. It's not a super complicated model. So any other questions about this? Yeah.
We'll discuss maybe the previous slides. I mean, when you model the loan,
This one here.
the loan, are they constrained in terms of how much they can borrow?
Yeah. So the way that we're doing it is we're using the Stafford loan. So we're basically we're assuming the way that you borrow is you borrow from using the rules of the U.S.
So you have
We're using institutional features now, which isn't total. You can borrow through other channels other than this, which we're not allowing for. Yeah.
When I think about dropping out, one of the things that comes up is like a consumption value of schooling. Should I think of that as part of like high school GPA or something like that as getting at your consumption value? I don't know how to think about that. How to think about whether it's harmful to you, and that's why people come out, or if it's. Does that make sense?
Yeah, no, it does make sense. So, yeah, I mean, a lot of it's going to be your epsilon shock, right? And this is like a more sophisticated model. We would have something like a learning model, but telling the difference between a learning model and just a straight epsilon shock model in practice is hard, right? So basically, these epsilon shocks are going to arrive, and they're going to say, a more general model might allow this thing to be evolving over time rather than to be IID, but in practice, I don't think it really makes that big of a difference in practice. So think about these epsilon shocks as when I go to college, I learn whether my epsilon is big or not. So I learn whether it is that I like college or not. If I like college, I decide to stay in. If I don't like college, I decide to leave.
Only if it's like correlated with some of your other characteristics, like your family income or
Say it again?
if your consumption value of schooling is somehow related to some of the other things in the model, like your access to funds or, that.
Yeah, but it will for this, right? So if I have high income parents that are giving me lots of money, then I can consume a lot, and this thing is be relatively high. If I'm really low income and I can barely afford my tuition, C is going to be really low, which means C to the 1 minus gamma is going to be really, really low, and I'm not going to go to college. So this part is really picking up maybe all of the interesting economics that's going on, and this is part at some levels of stuff that we can't explain, and we're going to say is taste. Okay. All right, so the way that we're going to estimate this model is by indirect inference, and I partly want to use. To me, this one of the things I really like about indirect inference is doing this kind of work. So what if you don't know what indirect inference is? Basically, indirect inference says you go to the real world, you measure you do a bunch of stuff. You measure a bunch of characteristics, and we're going to call that data hat. So this comes directly from the data. Okay. Now what I'm going to do is I'm going to write down a structural model, and in this case, a structural model is a data generating process. So if you give me a value of theta, I can generate the data, and then whatever I did to the actual data, I'm going to do exactly the same thing to the data that I generated from the model. If I have the data generating process right, then these two things should be the same. Okay, so I look for the value of theta that's going to get this thing to be as close as it can to that thing. So it's a very intuitive idea. Simulated method of moments is basic. I think of them, some people argue they're the same thing. To me, indirect inference is a little bit more general because it doesn't have to be a moment. You can construct theta hat however you want. It could be a simple moment, it could be a regression coefficient, it could be a coefficient you get from an RP, or it could be a coefficient that you get from an experiment, which is what we're doing here. So by doing this, we're going to be able to combine all of these different types of data. So from the NLSY, we're going to have sort of key variables with demographics, this Markov model for schooling, regressions for loans and for grades. And then we're also going to have the moments from the experiments. So not everything that they have, but we're going to pick key moments from the experiment. So we're going to try to reconcile one model to reconcile both the NLSY data and the experimental data, put them all together, and then let's see what we learn by putting this stuff all together. Potentially, we can use this to think about different types of policy experiments. Yeah. There's a whole big philosophy about whether you should do that, whether you should take one out and use it for validation, or you should use them or use them together. I get into an argument with my colleague Chao Fu about this because I'm very much on the side of not the validation. What I would rather do is use all of the information that you've got. In this particular case, I want to use them both because they're different. So they're providing me different information. Because basically the Wisconsin one is only telling me about completion, while the Nebraska one is telling me about completion, but it's also telling me a little bit more about whether you go and substitution between 2-year and 4-year schools. So this is a case where I would argue the information that the identifying information that you're getting from the two different experiments is different, and I want to use both of those pieces for identification. Now, if you had two experiments that were almost exactly the same, then it might be useful to do a hold down. So we are not actually we are there's a third experiment that we did that we are trying to validate that's bizarre. So this is this thing that Doug Harris did where they gave a bunch of money in Milwaukee to really poor kids. So this is a low performing schools in Milwaukee. They basically told them as the freshmen that you're going to have. They said they're going to give you it's like $3,000-4,000 a year, which is enough to pay for 2-year schools. They gave them this thing. It requires doing well in high school. You see no effect on high school, and then they look at it. You actually see people go to 4 years at lower rates and go to 2 years at a little bit higher rates. And then you graduate a little bit. You graduate 2-year degrees at somewhat higher rates. So that's I'm fine. I think so that I don't know. We're trying to so we are trying to validate, and we can't. But let me say we can't explain the data right now very well either. This is the sense in which this is a preliminary thing. We're not. For those that went to Max's talk, he said I fit the data pretty well. If he fits the data pretty well, we're a disaster because we're not done. This is estimating these kinds of models. We need to play around. There's factors that we can estimate. At this point, we're pretty close. I think we have most of the main features of the data. We haven't nailed all the results. So this is the. There's a bunch more moments in this, but these are examples of data. So in the share of people that enrolled in 4-year college, the first year after graduating from high school, 2.8, 285, 307, 322. So these guys were pretty good. Some of these, this one we're off by 25%. So we're getting the main features. I think I'm going to show you some policy counterfactuals. Those are clearly preliminary, given that we need to fine-tune the model before we fit the data better, but I think kind of the main lessons that we're going to see are going to stick. Okay, so these are the standalone moments. These are the RCT targets. So this is the Nebraska and the Wisconsin thing. And since it's the very last seminar, to make sure you're on the ball, we change notation. So here 10% is 0.1. Here 10% is 10. Here I think we fit the experimental data pretty well. I mean, all of these things were within the confidence interval of the actual point estimate. So we're not nailing all of these things, but qualitatively we're pretty close. I mean, some of these things, like this is minus 1.5, this is 0.46. That looks like a horrible fit, but it's not. This is 1.5 percentage points. With a relatively big state. So these are basically both zero. So we're able to reconcile the fact that you don't see very much. That it's hard for us to give a negative effect on getting associate's degree from giving money to people that are going to 2-year college, but we can. The model can reconcile a very small effect. Okay, a negligible effect. These look pretty good, actually. So here are some pictures of the changes over time. So we fit pretty well. Okay, so now what I want to do is I'm going to do a few different counterfactuals, and this is a little bit, this is a kind of a weird experiment because some of these counterfacts, it's sort of identification of the model. So the tuition effects, right? The effects of tuition subsidies, those are extremely well identified. We got those from RCTs. The other things that we're doing, the other kind of counterfactuals, are more in the descriptive sense. So I can show you two kind of counterfactuals. One of it, I think, it's easier to interpret what it means, and it's clear to mean what it is it's causal, and that's moving tuition around. But then the other thing that we're going to do is we're going to change these underlying characteristics. Like holding everything else about the model, we're going to change these underlying characteristics and think about what this would be. It's kind of a structural version of multiple regression at some level. Okay, so here is the baseline. It might be a little bit different than the raw data because we're not fitting the raw data perfectly, but you can see that we have the main features. So the first thing that we're going to think is about just getting rid of tuition. Okay, so tuition is suddenly going to become free everywhere, and tuition is becoming zero. There are some people that are getting financial aid. They get to keep the financial aid. So this is sort of an extreme version of things where we're setting tuition to 0, but parents aren't adjusting. Parents aren't adjusting. Financial aid is not adjusting. People are, and we need to do that. Some people have negative tuition because the scholarship they get covers more than just their tuition. So what do you see here? Like, again, is this big or is this small? I don't know what to say. I mean, moving stuff is hard, right? We've moved the fraction of people that had college degrees from something like 37% to something like 43%. So a 10% increase, that's a big number, okay? But what is the experiment here? The experiment is getting rid of all tuition in the United States. That's a really expensive program, okay? So it matters. You know, it lowers, it increases college graduation, increases graduation conditional on applying by a fair amount. It doesn't do much in terms of graduating with a 2-year degree. So it's changing things. But given the size of it, and it's not a trivial effect, but given the magnitude of the policy experiment that we're thinking about, I would say it's not a huge effect. One of the nice things about the structural model is we can look at, take the same person as a control and as a treatment, because we give them the same shocks and see how each person did. So this is the people where they were in terms of my 5 characteristics. This is where they were in the baseline. This is where they are in the tuition, where we sum up by 1 across columns within row. So 89% of the people that didn't go to college still didn't go to college, but 5% of them end up getting a BA. That's pretty good. I think the sum 2 year is particularly interesting here. So if I look at the sum 2 year, 82.5% of them are still sum 2 year. So most of them didn't change that much. The fraction that are getting associate's degree from this free tuition changes by almost nothing, right? It just goes up by a single percentage point. So that's not so good. But what's cool here is that this thing goes up by 12.5%. Okay? So what is this suggesting, at least within the context of this model, the version that we have now? Maybe we shouldn't be, if we gave these 2 year guys more resources, they wouldn't necessarily complete, we want them to complete the 2 year. That's not what they do. They take that money and they go to get a 4-year degree, and a non-trivial number of them end up actually completing a 4-year degree. So that makes the dropout seem not so bad. Among the sum 4 year, about a quarter of them graduate when they wouldn't have graduated otherwise. So again, these are not trivial effects. There's a few. If you look in the lower, there's some numbers here. Just because of the way the shocks work in the model, you can do things in different orders, so you can end up doing things that are counterintuitive. But you can see it's not very big. We can look at this experiment for blacks. Again, you see larger effects for blacks than you do for the population. We can look at it. This is for the lower tercile of family income. It does a fair amount for them, though the college graduation is still pretty low. So even making college free, it would still only be 30% of the lowest tercile that would graduate. Low GPA, the guys with low GPA are not gonna benefit that much from them because they have trouble going to college. Okay, the next thing that I did doesn't matter, and you probably already knew that it didn't matter from everything that I showed you in the experiments. Now we do something that's on the table is let's make 2 year tuition. So 4-year tuition we don't touch. We make 2 year tuition free. What happens? Almost nothing, right? I mean, this goes up by a little bit, but you almost can't, unless you squint, you really can't see much. So it's not, again, you really didn't need the structural model. You could see that out of both experiments. I don't understand this. I'm not sure this is right, but here's what I get. Basically what we're gonna do is we're gonna hold everything else constant, increase family income by 1 standard deviation, and we see nothing. Now it's not increasing standard family because we have this net tuition where you get scholarships. Increasing family tuition isn't strictly good, right? That the donation you get goes up, but the tuition you get goes down. So we see almost nothing for standard deviation. This is, I don't know what to call this. This is sort of the black, I would call it the black residual. Like we're sticking everything else on the model. We have this coefficient on black in a bunch of different places. So it's what black explains is not explained by the rest of the model. Here you see, and it's very similar to the multinomial logit thing that I showed you earlier. You see that blacks would actually, if we got rid of the black coefficient and made blacks look like whites, in every other, only in that one characteristic, things would actually look worse. Okay, so again, this is explained by GPA, APT, family income. That explains a lot of the black-white difference. After that, it actually looks like blacks go to college at higher rates. Female, this is actually sort of surprising, and this comes back into the GPA. We see very little difference between men and women once we control for all of this stuff. So I think it's really the high school GPA and the college GPA that are giving the main differences here. Here's the final thing that I want to talk about, and maybe the most interesting, is now let's think about increasing GPA, high school GPA, by a standard deviation. And for people that know the US system, a standard deviation is like half of a point. Okay, so it's like from a mean of, it's like from a B to a B plus, or you know, a little bit more than that. That has a huge effect, right? So the fraction of people going to college goes up by a lot if we could increase GPA. The fraction of people graduating from college goes up well above 50%. So this is a much larger effect than getting rid of tuition. I don't know exactly how you calibrate these and how you put them on the same scale, but we're getting twice as big an effect if we could do that versus if we can make tuition totally free. I can do the sort of the same picture here, and it looks very similar to what I saw before, but even stronger. So it's like, look at the sum 2 years. So these guys a quarter of them would end up getting BA degrees when they went to 2-year college and didn't even get an associate degree. So this GPA is sort of the 4 years. You get 34% of them are going to graduate. They weren't graduating before. I have 2 minutes, but I'm done. I can do the same thing for blacks. I see similarly large effects. I can do the same thing for the low-income group. Again, effects are smaller, but I'm almost doubling the fraction of kids that are going to college. Low GPA, they're still not doing great, but they're doing better than they were. So that's it. So this is again very preliminary. The model's going to change. We're going to add different things to understand things better. We're going to get the fit together. But I think these the main lessons that we get from the counterfactuals, I strongly suspect we're going to see similar things. 3-4-year tuition increases 4-year attendance, and it increases graduation. But increasing GPA, increasing high school GPA does considerably more. Okay? So here's another question: what the heck does that mean? Like, it depends on what you think high school GPA. Like, clearly, it's not causal. Like, if we just took a high school student and we added 0.5 to their GPA, we would not expect their college graduation rates to skyrocket. So clearly, clearly this is not a causal effect of GPA, but GPA is picking up something. The question is, what is it picking up? Is that malleable or not when we think about policies? So the extent that it's picking up something like some sort of non-cognitive skills like grit or something like that, then there's maybe not that much we can do about it. So students that worked really hard and pushed really hard in high school did the same thing in college, and that leads them to succeed. There's not that much we can do about it. However, if it's, call it college preparedness or call it human capital, call it a proxy for human capital accumulation while in high school, if that's what it is suggesting there's something we can do about it. This is suggesting if we really want to, this is what I think. After doing this, even though I can't say that we've actually proved this, if you really want to increase college outcomes, the best place to invest is earlier, high school or prior to high school, to get kids more ready for college. And that's, I think that's what the GPA is proxying for. Further work, hopefully we'll figure that out. Okay, I'm done. You had a question?
Yeah, just on that very last point, did you have correlation between high school and your college learning rates?
I mean, no, we don't, because high school GPA enters the college, enters everywhere. So at some level, we could, yeah, you can think about it as a correlated thing. So the learning rate is the residual, but the real learning rate is going to be some coefficient in high school plus AIDA. So it's correlated in a way, because high school GPA enters everywhere that the DY enters.
Another question? Yeah, the comment?
Yeah.
So I was thinking, could you also simulate some cognitive skill by one standard deviation? So the guy that same similar exercise with good GPA, but
Yes.
if you change GPA, a lot of things change, perhaps cognitive skills.
Absolutely. Like that, yeah, that's, I mean, as I was getting ready this presentation, that's exactly what we should do. I like to just go back to the simple multinomial logit stuff. We have measures of non-cognitive skills and the NLSY. We'll see how they do. I suspect it's gonna matter, but it's not gonna wipe out the GPA effect, but stay tuned. Yeah, but excellent idea.
Time for one more. Go there.
If you think about these policies, could we expect something to happen in the labor market so that age premium to college and have this huge shift in the number of professionals as well? Is it possible to think about the feedback here from what's happening in the labor market to the college decision?
So I have a paper that shows that when we think about tuition subsidies, that if you look at general equilibrium and partial equilibrium effects, the partial equilibrium effects are 10 times larger than the general equilibrium effects. My only answer to that question has to be it could matter a lot. We're not going to try to model that here. Think about this as a partial equilibrium, thing. So that we're not going to change the whole U.S. But something like Wisconsin we're going to get made free tuition in Wisconsin. Wisconsin is small relative to the United States. We're not going to. You're absolutely right. Like in general equilibrium, as we stick more college graduates in, the return to college is going to decline, and that's going to lower the fraction of people.
Okay, I think we're wrapping up. So we thank Chris again for a great talk.
Ok, possiamo chiudere.
Last time you hear my voice almost, right? So here's the information
Chiudiamo.
to know. Bus.